16. Electromagnetic flow sensors. Electromagnetic flow sensors can be used to measure corrosive liquids such as acids, alkalis, salts, or liquids mixed with solids, like slurry, sewage containing a lot of sundries, and viscous media. It is widely used in chemical engineering, metallurgy, papermaking, pharmaceuticals, textiles, brewing, food, environmental protection, chemical fiber, water conservancy, and other industries. Next, let's start learning about electromagnetic flow sensors. First, we learn the electromagnetic flowmeter. Flowmeter is a sensor and instrument for measuring flow. It is an industrial automation instrument for measuring the flow of liquid, gas, or vapor in pipes or open ditches. It is one of the important instruments in industrial measurement. With the development of industrial production, the requirements for the accuracy and range of flow measurement are getting higher, and the flow measurement technology is developing all the time. In order to adapt to various uses, various types of flow meters have come out one after another. At present, more than 100 flow meters have been put into use. Electromagnetic flowmeter is an induction meter based on Faraday's law of electromagnetic induction, which is used to measure the volume flow of conductive medium in a tube. Next, let's start learning about electromagnetic flow sensors. From different angles, flow meters have different classification methods. There are two commonly used classification methods. One is to classify according to the structural principle of the flowmeter. And the second is to summarize and classify according to the measurement principle adopted by the flowmeter. Electromagnetic flow sensors are an integral part of electromagnetic flow meters, which is used to measure the instantaneous flow and volumetric flow of conductive liquid and slurry. Electromagnetic flow sensors can be divided into two types in structure: split type and integrated type. The electromagnetic flow sensor and the electromagnetic flow converter are matched to form a detachable electromagnetic flow sensor. The sensor and the converter are independent respectively. The sensor is installed on the pipeline, and the converter can be installed within 200 meters from the sensor. The working principle of the electromagnetic flowmeter is based on Faraday's law of electromagnetic induction. When a conductor moves in a magnetic field, there will be an induced electromotive force at both ends of the conductor in a direction perpendicular to the direction of the magnetic field and the direction of motion. The magnitude of the electromotive force is directly proportional to the velocity of the conductor and the intensity of magnetic induction. When the conductive fluid flows at an average flow rate V meters per second through an insulating tube with an inner diameter d meters and fitted with a pair of measuring electrodes, and the tube is in a magnetic field with a uniform magnetic induction intensity of B Tesla, then the electromotive force E volt is induced on the pair of electrodes perpendicular to the direction of the magnetic field and the direction of the flow. It can be seen from the electromotive force that when B is a constant, the flow QV is proportional to the electromotive force E. The electromagnetic flow converter provides a stable excitation current to the excitation coil of the electromagnetic flow sensor, so that B is a constant. At the same time, the electromotive force induced by the sensor is amplified and converted into a standard current signal or frequency signal for the display, control, and adjustment of flow. Electromagnetic flow converters and different types of electromagnetic flow sensors are matched to form an electromagnetic flow meter system, which is used to measure the volumetric flow of conductive fluid in closed pipes. It is widely used in petrochemical industry, iron and steel metallurgy, water supply and drainage, water conservancy, irrigation, water treatment, environmental protection, sewage total control, papermaking, medicine, food, and other industrial and agricultural departments for measurement and control of the flow and production process. It is suitable for measuring the total amount of conductive liquids. Finally, taking the electromagnetic flowmeter and water treatment system as an example, I'll explain the advantages of the electromagnetic flowmeter. There are many types of flow meters, and the measurement principles and structures of various flow meters are different. But electromagnetic flow meters are commonly used in water treatment systems. Mainly because electromagnetic flow meters have the following advantages. 1. The measurement is not affected by the temperature, pressure, or viscosity of the measured liquid. 2. No pressure loss, continuous measurement, high measurement accuracy. 3. The aperture range and measurement range are large, and the measurement range is continuously adjustable. It has nothing to do with the velocity distribution. 4. Good stability. The output is a standardized signal, which can easily enter the automatic control system. 5. The inner wall of the transmitter conduit is lined with a lining material, which has good corrosion resistance and wear resistance. 6. The converter is small, having low power consumption, strong anti-interference performance, and is convenient for field observation. The lining material of electromagnetic flow meters used in water treatment systems is mostly chloroprene rubber, because of its good wear resistance. When installing, pay attention to stay away from the external electromagnetic field source so as not to affect the working magnetic field and flow signal of the sensor. When the sensor is installed horizontally, the central axis of the two electrodes is required to be in a horizontal state to prevent the deposition of particles and impurities and affect the work of the electrode. In this lesson, we learned the application of electromagnetic flow, the working principle and practical application of electromagnetic sensors. After class, you can search information to learn what are the industrial applications of electromagnetic flow sensors. That's the end of this lesson. See you next time.